Hello class, today we are going to talk about the properties of special parallelograms. So in the previous video we talked about parallelograms in general. Today we're going to talk about some special cases. All right. So just to review, with parallelograms we have these properties right here. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals will bisect each other. This is true for all parallelograms. Doesn't matter what parallelogram it is, this is going to be true. Now, you have some special cases that will have some other things in addition to these right here. So one of those special cases is the rhombus. A rhombus has all sides congruent. Okay, a rhombus is a type of parallelogram. So all of these things are true for a rhombus, but in addition to that, all of the sides are congruent, and there will be some other things we'll talk about in just a second. The other special parallelogram is the rectangle. And in a rectangle, all the angles are congruent. You have all right angles, right? 4 right angles, that's a rectangle. All right? All of these properties here are true for rectangles as well. This is not. This is only rhombuses. This is true for rectangles, but it's not true for rhombuses, okay? So these properties here, these are true for everything. These are special cases. This is a special case. Now, what happens if you have all the sides congruent like a rhombus and all the angles congruent like a rectangle? Well, then you have a square. A square has all sides congruent and all 4 angles are right angles. So a square is a rhombus because the sides are congruent. A square is also a rectangle because the angles are right angles. All right? So all of the properties, everything we talk about for parallelograms, true for squares. Everything we're going to talk about here in just a second for rhombus is true for squares. Everything we talk about for rectangles, true for squares, because squares are all of them. All right, so let's take a look at this rhombus. We have some special properties for rhombus. So here it is. Got a rhombus. All 4 sides are congruent. And we've got some special things going to go on with the diagonals. The first one is the rhombus diagonals theorem. It says the diagonals of a rhombus are perpendicular. All right. So if you remember from the perpendicular bisector theorem, any point that is equidistant from the 2 endpoints is going to be on the perpendicular bisector. And as we see, since the sides are congruent, point B is the same distance from A as it is from C, and therefore this is the perpendicular bisector. So the diagonals are perpendicular to each other. All right. The other one we're going to have here is that the opposite angles, the rhombus opposite angles theorem. The diagonals of a rhombus will bisect the opposite angles. Every single time if you have a rhombus, the diagonals are going to bisect all of the angles. All right. The angles are going to get bisected by the diagonals in a rhombus. Neither one of these are true for any parallelogram that is not a rhombus. These are only true for rhombi. Rhombi is the plural of rhombus, not rhombuses. Most people will accept rhombuses, but the actual plural is rhombi. R-H-O-M-B-I-I. So, anyways. So, in a rhombus, the diagonals bisect the angles, and they are perpendicular to each other. Not true for any other parallelograms. Rectangles, we also have a special little property of rectangles. Since all of the angles are right angles, the diagonals are congruent. Rectangle diagonal theorem, the diagonals of a rectangle are congruent. They do still bisect each other because it is still a parallelogram, but they are also congruent, unlike other parallelograms. As we can see in the rhombus, BD is clearly shorter than AC. All right? But in a rectangle, the diagonals are both the same length. All right? So for a square, this is true for a square because it's a rectangle, and both of these are also true for a square because it is a rhombus. Okay? Every property for all of these is going to be true for squares. Now, let's take a look at this. We want to classify these quadrilaterals. Notice it says that these are not drawn to scale. Okay? All of these look like rectangles. However, On number 1, notice the markings. The markings say that all 4 sides are congruent to each other. That's not the property of a rectangle, is it? No, that's the property of a rhombus. And that's what this is. It looks like a rectangle, but the markings say it's got 4 congruent sides, and therefore it is a rhombus. All right, so what about number 2? Let's see, number 2, we have the diagonals, and the diagonals are all congruent to each other, aren't they? All right. Diagonals are congruent to each other, so that makes it a rectangle. Remember, a rectangle has 2 congruent diagonals. Okay, diagonals are congruent to each other, so it's a rectangle. Okay, on number 3, let's see here. We've got opposite sides parallel, so we've got parallelogram stuff going on. Not parallel, opposite sides are congruent. And notice the diagonals. The diagonals are marked as being perpendicular to each other, and that makes this which one? Yeah, that makes it a rhombus. I said rhombus has perpendicular diagonals. Even if it doesn't look like they're perpendicular, they're marked perpendicular. This is a rhombus. All right, let's take a look at number 4. Well, number 4, we've got diagonals bisecting the angles. Well, that makes this a rhombus, except you'll also notice all of the angles. All of those angles are congruent, aren't they? They all have the same little, just one little arc there, right? So which one has congruent angles? Well, that's a rectangle. So which one is this? Is this a rhombus or is it a rectangle? Well, the answer is it's both. And if it's both, then it is a square. All right? So pay attention to the markings. That's going to tell you what it is, not just the way it looks. All right? Because things aren't always drawn to scale. You got to pay attention to that. All right, let's do some other examples here. So here we have the diagonals of a rhombus, rhombus ABCD. They intersect at point E. All right, we're giving the measure of angle BCA is 44 degrees. The measure of the measure of side AB is 9, and the length of AE is 7. I want to figure out these. So let's see, we've got BC. Where's BC? BC. BC is a side. How are we going to know how long that is? Well, it tells us right here that this is a rhombus. And the definition of a rhombus is that all of the sides are the same length. And so if side AB is 9, then side BC is also 9, because that is the definition of a rhombus. All right. Let's see, AC. Where is AC? AC is the length of this entire diagonal. Well, you know that this piece here is 7, and you know what? A rhombus is still a parallelogram, right? And since a rhombus is a parallelogram, I know that E is the midpoint of AC, because the diagonals bisect each other. So if AE is 7, EC is also 7, and so AC is 14, because the diagonals of a parallelogram bisect each other. Even though it says it's a rhombus, it's still a type of parallelogram. And so all of the parallelogram properties work for the rhombus. Okay, what's next? We have the measure of angle ADC. ADC, that's right here. Okay, well, I don't have a whole lot going there. The only angle I've got is this one. It's not even the entire angle. So let's see. I know this is 44 degrees. We can find this whole angle here, right? Because I know that since this is a rhombus, the diagonal bisects the angle. So if this is 44 degrees, it's only half of the angle. This other piece here, this is also 44 degrees, because the rhombus opposite angles theorem. And so 44 degrees and 44 degrees, this whole thing is 88 degrees. And since this is a rhombus, it makes it a type of parallelogram. I know that the consecutive angles are supplementary. Supplementary means they add up to 180, and so I can just subtract 88 from 180, and so 92. And so the measure of angle ADC is 92 degrees, because the consecutive angles of a parallelogram are supplementary. All right? So remember, just because it's a rhombus doesn't mean it's not a parallelogram. It's still a parallelogram, and all of these parallelogram theorems still work. All right, so let's take a look at this. Here we have rectangle EFGH, and the diagonals intersect at point I. So, given that the measure of angle HFG is 31 degrees, right there, and the length of EG is 17. Let's see, EG is this segment here, so that's the entire diagonal. Notice they didn't mark it on there, so we're just going to have to remember that. And they didn't do that because if they put a 17 right here, it would just look like it was EI, not the whole thing. All right, same thing here, it would look like it was IG. So they just put it in the thing. So EG is 17. Okay, we need to find the indicated measures. So first one they want is HF. So HF is the length right there. So that's the other diagonal, right? Well, it gave us one diagonal. How are we going to find the other diagonal? Well, since it's a rectangle, we know the diagonals are congruent to each other. So if EG is 17, HF is also 17, because the diagonals of a rectangle are congruent to each other. All right, next we want the measure of angle EFH. So EFH. So that is this angle right here. Well, it's not going to be 31. This is not a rhombus, so the diagonal does not bisect the angle. Okay, so what do? Well, it's a rectangle, so I don't know about this angle. Well, I know that if it's a rectangle, then by definition, it's 90 degrees, and therefore I can subtract 31 from 90, and I end up with 59, because the definition of a rectangle is that all of the angles are right angles. All right, so last thing we got, what about a square? So here we have square LMNP intersects at point K on the diagonals, and all it gives us is that the length of segment MK is 1/2. See, it wants the length of segment NK. Okay, well, let's see here. Squares. Well, we don't have any properties of squares. Squares are just everything else. So what do we know about diagonals? Well, since it's a parallelogram, we know diagonals bisect each other, so this is also 1/2. That's not the one we're looking for. We're looking for this one. But it is also a rectangle, right? And if it's a rectangle, the diagonals are congruent. So this piece is congruent to this piece because it is a rectangle and the diagonals are congruent. So since all of these are congruent to each other, NK is 1/2, same as MK is. All right? Okay, what do we got next? We've got the measure of angle PKN. Let's see, so that's PKN. Well, it didn't give me any information about angles anywhere up in the instructions, anywhere in the diagram. But let's see here. So it's a rectangle, which honestly doesn't tell me anything at all. So what about a rhombus? Rhombus. Diagonals of a rhombus, we do know this angle here. Because remember, for the diagonals of a rhombus, they're perpendicular to each other, which makes this a 90-degree angle. All right? Okay, so, because remember, a square is a rhombus and a rectangle. It's both. Anything that works for one works for the other. It works for squares. So let's see, the measure of MNK was MK. MNK. Okay, so we're looking for this angle. Again, it gives me no information. Let's see, we said it's a rhombus and it's a rectangle. So let's see, this, well, it's a rectangle. Rectangles have right angles, right? All right angles because it's a rectangle. But we're not looking for the whole thing. Oh, we're just looking for MNK. We're just looking for this piece of it. Well, it's also a rhombus. If you remember that diagonals of a rhombus will bisect the angles. And so if the entire thing is a right angle, it measures 90, we just want half of it because it is bisected because it is a rhombus. And so the measure of that angle is a 45-degree angle. All right? So there's that. Just to recap, remember, 1, use things based on the markings, not on what it actually looks like. Go based on how it's marked. All right? Rectangles have congruent diagonals. All right? The diagonals of a rectangle do not bisect the angles. Okay? Not going to happen. They're congruent to each other. They are not at right perpendicular, and they do not bisect the angles. Diagonals of a rhombus does bisect the angle, and they are perpendicular to each other. They are not congruent. Okay? They are not rectangles. So all they do is they bisect the angles, and they are at a right angle to each other. Okay? Notice, however, that both of these, rhombus and rectangle, the diagonals still bisect each other. They still cut each other in half. They intersect at the midpoint because rectangles and rhombi are still parallelograms. So all of this stuff here that's true for parallelograms is also true for a rhombus. All of this stuff also true for rectangles. And since a square is a rhombus and a rectangle, everything works for squares. Squares are rhombi, but rhombi are not squares. Squares are rectangles, but rectangles are not squares. And these are all parallelograms. Even though this parallelogram is not a square, the square is a parallelogram. All right? So, hopefully you found that useful, and I will see you in the next video.